Hello friends, in today's question, the displacement of a damped harmonic oscillator is given by x of t e raised to power minus 0.01 t cos of 10 pi t plus phi. Here t is in seconds. The time taken for its amplitude of the vibration to drop to half of its initial value will be close to. So in this case, it is given as a damped oscillator, and we have to find out when the amplitude becomes half of its original value. So let us first of all write the equation which is given to us, and that equation is nothing but equation for the displacement. So you can say the displacement of damped oscillator and it is given by the equation x of t e raised to power minus 0.1 t cos of 10 pi t plus phi. And let us try to understand what are the various components of this displacement equation. So first part is our e raised to power minus 0.1 t, e raised to power minus 0.1 t, and this is the, you can say, amplitude, but it is exponential decaying amplitude. Okay, this is exponential function, and here minus means it will be a decaying exponential function. So we are going to call it as a exponential decaying amplitude. This is our exponential decaying amplitude. And because of this decaying amplitude, it will be a damped harmonic oscillator, which basically means that the amplitude of the oscillation is going to decay and come at approximately equal to 0 when time is infinity. And the second part is our cos of 10 pi t plus phi, and that is called as a oscillatory part of the motion. This is called as a oscillatory part of the motion, wherein 10 pi represents the angular velocity. 10 pi is angular frequency, not velocity, angular frequency, and t, as it given the question itself, is in seconds. T is the time in seconds. T is time in seconds. So it's given that the amplitude of vibration dropped to half of its initial value. So let us first of all find out what will be the initial value. Okay, initial means when time is equal to 0, what will be its amplitude. Amplitude at t is equal to 0. So let us call this as a naught, and this will be equal to e raised to power minus 0.1 multiplied by 0, and this will be equal to 1. So we got that the amplitude at time is equal to 0, a is equal to 1, and this amplitude starts from 1 and it is going to continuously decrease over time due to the exponential factor. So we can say from here, and it decreases over time due to exponential factor and where the factor is e raised to the power minus 0.1 t. And let us write the problem statement, what we are actually going to find out. So the problem statement, we can say that find the time t when the amplitude drops, when the amplitude drops to half of its initial value, to half of its initial value. So it basically means that we have to solve for t when the amplitude at certain this value of t will be equal to half of a naught, because a naught is initial value, and we just found out that our a naught is equal to 1. So we can say we have to find out the time t when this amplitude becomes equal to 1 by 2. Or we can say a of t can be written as e raised to the power minus 1 point t is equal to 1 by 2. So we have to solve this equation. So in order to solve this, we are going to, let us call this as equation number 1. We are going to take natural log to both sides, taking natural log to both sides in equation 1. So we can write ln e raised to the power minus 0.1 t is equal to ln 1 by 2. So this becomes as minus 0.1 t, and this becomes natural log of 2 minus taken as 1 by 2. We are going to write natural log of 2, and from here we can say that 0.1 t is equal to natural log of 2 is given at 0.693. So this will be t, and we have 0.693 divided by 0.1. So this comes as 6.9 seconds, and we are supposed to find out close to. So we can say time, which is our 6.9 second, is approximately equal to 7 seconds. So this is the time taken. This is the time taken for the amplitude to drop half of its initial value. Amplitude to drop half of its initial value, and the option available to us is closest is 7. So D is the correct option. So therefore we can say that option D is correct. So this completes the question. Thank you.